Welcome. In this particular video, we'll be analyzing function notation absolute value part 3. Let's take a look at our first example. Example 1. Given f of x is equal to absolute value of x minus 4, find f of 2. Well, remember that x is your input, and for that particular input, the output will be absolute value of x minus 4. Let's evaluate this f of 2 using two different methods. Method 1 will be based on the description method. So let's describe what's going on. In order for us to generate the function f of x, the first thing we do is we select a number or pick a number. That's what we call x, or our input. Then to that x, we're subtracting 4. So that's our second step. And that's how we generate x minus 4. And the last thing we're going to do is to take the absolute value. Now, since we have the 3 steps, we can actually find out what is the output for the corresponding input of 2. So pick a number, let's say we pick 2, then subtract 4, so we have 2 minus 4, which is negative 2, and then take its absolute value. So absolute value of negative 2 is equal to 2. Therefore, we can say that f of 2 is equal to 2. Now, this is how we obtain the value for f of 2 using the description method. Let's use a different method to double check our work. So let's say we have method 2, the substitution method. For the substitution method, all we're going to do is to substitute in the 2 wherever we see an x. So we said we have f of 2. That should be equal to the absolute value of 2 minus 4. Now we can rewrite this as f of 2 is equal to the absolute value of 2 minus 4, which is absolute value of negative 2, which happens to be 2. Therefore, we can conclude that f of 2 is equal to 2. As part of an extension, we can say the following. Here we have the point with coordinates 2, 2. Why is that the case? How can we say that we have the point with coordinates 2, 2? Well, because your input or x value is 2 and your output or y value is 2. So we can actually say we have the point with coordinates 2, 2. Let's see another example. Example 2. Given g of x is equal to the absolute value of x plus 5, find g of negative 2. Once again, let's pay close attention to our input. In this case, our input happens to be x, and your output happens to be absolute value of x plus 5. Now, our goal is to find out what is the value for g of negative 2. To do so, let's use both of the methods that we used previously. So method 1, based on the description. So notice, in order for us to generate g of x, the first thing we're going to do is to pick a number. Let's call that number x. The next thing you're doing to your x is to add 5. So that's step 2. Add 5. And that's how we generate x plus 5. And the last thing we're going to do is to take the absolute value of that. So step 3, take its absolute value. Now, these are the steps that we need to generate g of x. However, in our particular case, we have that the input is now negative 2. So when it's time to pick a number, let's say we picked negative 2. Now, we're going to add 5 to it. So we have negative 2 plus 5, which gives you 3. And then you take its absolute value. So you take absolute value of 3 is equal to 3. Therefore, we can say that g of negative 2 is equal to 3. Let's double check our work by using method 2, also known as the substitution method. So what does the substitution method consist of? Well, simply, all we're going to do is to substitute in the negative 2 wherever we see an x. So yes, let's say we have g of negative 2 is equal to the absolute value of negative 2 plus 5. So let's write that down. Now here we have that g of negative 2 is equal to the absolute value of negative 2 plus 5, which is 3, and the absolute value of 3 happens to be 3. Notice that regardless of which method we use, we still get that g of negative 2 is equal to 3. Now, as part of an extension, we can say that we have the point with coordinates negative 2, 3. How do we know that? Well, we know that because your input value is negative 2, or that's equivalent to your x value, and your output value is equal to 3, also equivalent to your y value. Let's see one more example. Example 3. Given h of x is equal to absolute value of x minus 7, find h of 0. Again, your input is x for this function h, and your output is absolute value of x minus 7. Now let's go ahead and evaluate h of 0 based on the two previously described methods. So method 1 will be the description method. Now let's see, how do we generate the function h of x? Well, the first thing we're going to do is to pick a number. Let's call that number x. Now, if we pay close attention, the next thing we're doing to your x is to subtract 7. And that generates the expression x minus 7. And the last thing we do is we take the absolute value of that. So take its absolute value. Now, by us taking the absolute value, we actually obtain absolute value of x minus 7. However, in this case, our input happens to be 0. So that's the number we're going to pick. So we said, okay, we start off with 0, then we subtract 7. So we have 0 minus 7 gives you negative 7. And lastly, you take its absolute value. So we have absolute value of negative 7 is equal to 7. Therefore, we can say that h of 0 is equal to 7. Now let's double check our work by using the substitution method, or method number 2. Once again, method number 2, or substitution method, it's based on the fact that we're substituting in the value for x. So we have h of 0 is equal to the absolute value of 0 minus 7. And 0 minus 7 happens to be negative 7. So we're taking the absolute value of negative 7, which is 7. Therefore, we can say that h of 0 is equal to 7 as well. And once again, regardless of which method we use, we still obtain that h of 0 is equal to 7. Now, as part of an extension, we can say that we have the point with coordinates 0, 7. Why is that the case? That is the case because your input, or x value, happens to be 0, and your output, or y value, happens to be 7. So this concludes this video on function notation, absolute value functions part 3. Thank you for watching, and have a wonderful day.